Hi everybody, this video we're going to be all about the technology used in the game Witcher 4, at least those that I actually read about and found about. Now of course there are many other technologies out there, but the thing is that it really comes to life when a game, especially a game that many love, make use of these technologies, especially many of these technologies in a single game. Of course, many games can benefit from it, but especially open world games and those games that also employ human characters and those who want to portray a more realistic view of the world. But then I mean in terms of art style. And of course, if you add fantasy into it and you can create some really crazy things, that some of the features in certain game engines really help bring these amazing, beautiful, creative worlds to life. All right, so let's begin. So CD Projekt Red, highly anticipated, The Witcher 4, marks a pivotal moment, not just for the beloved fantasy series, but for the entire gaming industry. After years of anticipation, a recent glimpse into its in-game engine capabilities that reveal visuals that are nothing short of breathtaking. Now, this new chapter in the saga transport the players to the never-before-seen region of Kvir, promising vast immersive landscapes and a fresh monster contract for Ciri, who was featured as the protagonist in the tech demo that was featured yesterday as of time making this video. So crucially, The Witcher 4 is being built on Unreal Engine 5.6, a testament to CD Projekt Red's strategic partnership with Epic Games, which commenced in 2022. Their collaboration extends beyond merely licensing an engine. It signifies a deep, ongoing effort aimed at pushing the boundaries of open-world game development. The tech demo showcased running smoothly at a targeted 60 frames per second on PlayStation 5, highlight a suite of cutting-edge Unreal Engine 5 technologies. These enhancements are set to power the game across all platforms, PC, PlayStation, and Xbox, promising both stunning visuals and fluid performance. Now, the technologies harnessed for The Witcher 4 are designed to deliver an unparalleled open-world experience. This includes everything from hyper-realistic environments and lifelike characters to seamless exploration and dynamic crowds. These advancements are not solely about achieving higher graphical fidelity, they are about creating a world that feels truly alive, responsive, and deeply immersive. Now, to provide a clear understanding of the technological backbone of The Witcher 4, the following information I'm going to show you offer you a concise overview of the key Unreal Engine 5 technologies confirmed for the game and their direct impact on the player experience. So we're going to go over all of them that I actually listed here. I'm talking about what they do and the impact of the game, and then I'm going to explain each one in more depth. So first of all, Nanite. This is renders an insane geometry detail without slowdown. In terms of impact of the game, basically every rock, ruin, and piece of architecture boasts film quality detail with no distracting pop-in. And the other one is really big, the Nanite Foliage, creating incredibly dense and realistic vegetation. And the impact on the game will be, well, lush forests, expansive fields where every blade of grass and leaf is rendered with stunning realism and dynamic movement. Even the lighting effect works beautifully with this technology. Lumen and hardware ray tracing, this provide dynamic realistic lighting and reflections. So in the game you're going to see believable light and shadows that react instantly, creating stunning atmospheric effect and immersive day and night cycles. In terms of visual shadow maps, this delivers high-resolution, consistent shadows. It adds incredible depth and realism to every scene with sharp, accurate shadows for all objects and characters. The FastGeo Streaming and World Partition, this enables seamless loading of massive open worlds, instantaneous transition between vast areas, no visible loading screen or pop-in, allowing for uninterrupted exploration of Kvir. MetaHuman Technology, you probably heard about that before, generates photorealistic, fully rigged digital humans. It leads to incredible lifelike NPCs and diverse crowds with expressive faces, avoiding the repetitive cloned villager, in quotations, feeling in the game. Unreal Animation Framework, UAF. This provides powerful fluid, performance-optimized character movements. Series combat in the game. Again, series combat and traversal animations are exceptionally smooth and realistic, even in busy scenes. The AML Deformer, machine learning deformer that adds subtle realistic muscle and clothing deformations. Characters feel truly alive with believable muscle flex, skin ripples, and natural clothing movement. Some people I've seen comment on the trailer, on the tech demo, that they saw that basically the clothing, the cap actually doesn't clip with the horse. It was that impressive. And the horse animation were incredible. We're going to talk about this in a moment. And Mesh AI that enables thousands of intelligent AI characters. And in the game, you're going to see bustling towns filled with diverse, dynamic crowds and epic battlefields teeming with reacting enemies. Alright, so that's kind of in a nutshell. Now, let's dive into each one and talk more about what each one does. So let's start with Nanite. I first experienced that on the PlayStation 5 with that Matrix kind of tech demo on Unreal Engine 5, as you can see here on the right. It was absolutely amazing, truly breathtaking. So imagine a world where every pebble, every crack in the stone, and every intricate detail on the monster's hide is rendered with absolute precision, without your PC or console breaking a sweat. This is the transformative capability of Nanite, Unreal Engine 5's virtualized geometry system. This groundbreaking technology employs a new internal mesh format and rendering approach to handle an astronomical number of triangles, often referred to as micropolygons, that were previously impossible to render efficiently in real-time games. Now, traditionally, game development relied on level of detail systems, level of detail in quotation, LODs, where objects far away were simplified to conserve performance, then swap to higher detail as the player approaches. Now, this often resulted in an excessively popping or jarring transition, breaking immersion. Now, Nanite fundamentally changes this paradigm. It intelligently renders only the detail that can be perceived by the player's camera, and no more. This means the system automatically manages LOD efficiently, eliminating popping entirely. Developers can directly import film quality assets such as high-resolution ZBrush sculpts and photogeometry scans into the game without the traditional performance constraints. So in The Witcher 4, this translates into hyper-detailed landscapes, objects, and architecture throughout the region of Kovir. So every ancient ruin, every tree, every object in the game will boast an unprecedented level of geometry complexity where it applies, making the world feel incredibly tangible and real. Now, the tech demo confirmed that Nanite was utilized extensively to render terrain and rocks with extreme detail without tanking performance. Now, this capability allows CD Projekt Red to design environments where every element, from distant mountains to foreground debris, maintaining a consistently high level of detail. Players will experience a world free from distracting popping or noticeable LOD transitions, enhancing immersion and making the world feel truly next-gen in its visual richness. This is a core enabler for the game's ambition to deliver high-fidelity open world at a smooth 60 frames per second. And of course, on the platform, it's not limited to that. It's the bare minimum. Now, this level of details and seamless streaming does come with a fundamental hardware consideration. Nanite relies on the rapid streaming of mesh data from disk-on-demand, consequently solid-state drives, SSDs. These are strongly recommended for optimal runtime storage, and you probably heard some developers mention this as a recommended for the game, or something it's a minimum even for a game, so they can actually benefit from that. This is not merely a casual suggestion, it is a fundamental hardware requirement for The Witcher 4. So it can deliver its promised visual quality and seamless experience. Now, PC player will need an SSD for optimal performance, while console players on the PlayStation 5 and Xbox Series X and S inherently benefit from the console's built-in high-speed SSDs, which are essential again for the rapid data streaming of Nanite demands. This illustrates how advancement in hardware directly enable new engine capabilities and, by extension, new possibilities in game design. Next, we're going to talk about Nanite Foliage. This was very interesting because, again, I saw something how it plays even without that when companies have their own game engine, like, for example, The Last of Us 2, which run on Naughty Dog own proprietary game engine. And I always wanted to know what happens if you take it even to the next level, create something really impressive. So Nanite Foliage, living and breathing ecosystems. So let's talk about that. So foliage, basically the lush forest, swaying grasses and dense brushes, is historically presented a significant performance challenge for game developers. Traditionally, it relied on mesh cards, which are mesh cards, again here in quotation, that's the kind of the term that's given to it, which are flat planes with textures simulating leaves. This was surprisingly expensive to render due to the overdraw, where the GPU draws many layers of transparent pixels that are ultimately hidden. Now, Nanite Foliage fundamentally shifts this approach by encouraging the use of actual 3D geometry for every blade of grass and leaf. Now, while it might seem counterintuitive to use more geometry, Nanite handles it far more efficiently than traditional methods. This results in increasingly dense, realistic vegetation that maintains exceptional detail at any distance, even across vast open-world environments. Features like preserve area ensure that distant canopies do not thin out, effectively maintaining visual density by redistributing lost surface area to remaining triangles. The system also supports advanced dynamic effects such as simple and advanced wind and enhanced subsurface scattering. This is, by the way, a snippet video from epigames.com where you can see the developer actually taking a tree and applying nanite to the tree. Now, the tech demo for The Witcher 4 specifically highlighted the use of nanite foliage rendering. This implied that the forests and fields of Kovir will be filled with unparalleled density and realism. Now, one can imagine Siri running through a meadow where every blade of grass sways individually in the wind, or exploring a deep forest where light realistically filters through dense, geometric-rich canopies. Now, the demo demonstrated how every bush, every tree look kind of handcrafted, yet the frame rate remained very stable based on what we've seen. This indicates that CD Projekt Red is not merely enabling a feature, they are fundamentally changing how they construct environmental assets. Now, this commitment to geometry-based foliage, despite the potential initial asset creation overhead, allows for a level of environmental realism and density that was previously unachievable. For players, this means a truly lush, believable, and performance-friendly natural world in The Witcher 4, where the environment itself is like a living, breathing entity. Furthermore, the inclusion of features like dynamic wind, enhanced subsurface scattering, and a player interaction system for Nanite Foliage suggests that the vegetation will not only be visually stunning but also dynamically responsive. Now, this adds a crucial layer of immersion, making exploration feel more grounded and believable as wind visibly affects vegetation, and light realistically filters through leaves, and the player's movement causes grass to bend or rustle. Now, if you play, for example, The Last of Us 2, you know how it feels when something like that is created well, especially with Ellie when she moves through the grass, and you can see the movement. It feels very immersive, very realistic, and very impressive. So I do expect something at least to the degree what we've seen in The Last of Us 2, and even more impressive with all the other technologies. Let's move on to Lumen and other ray tracing, things related to dynamic lighting and realistic reflections. Now, Lumen in Unreal Engine 5's fully dynamic global illumination and reflection system, basically what it does, it calculates how light bounces around the scene in real time, creating incredibly realistic lighting and reflection that react instantly to changes. This capability is often significantly enhanced by hardware ray tracing, which leverages dedicated hardware in modern GPUs to trace light rays with extreme precision, further improving performance for Lumen Global Illumination by eliminating CPU bottlenecks. In previous game development, lighting was often baked, pre-calculated, or approximated, leading to static scenes or less convincing dynamic effects. The Lumen and Huddle ray tracing revolutionized this by simulating how light behaves in the real world. If a light source moves or an object casts a shadow, the entire scene's illumination adjusts instantly and realistically. This means light from a torch will accurately illuminate a dark cave. Reflections in water will precisely mirror the surrounding environment, and shadows will be soft and diffuse or sharp and distinct, just as they would be in reality. For players, this translates into a stunning atmospheric effect, believable light and shadow play, and truly immersive day and night cycle. They dynamically transform the world. This should also, of course, lead to a world full of life with full dynamic lighting that, of course, also look very realistic and very convincing and immersive. Now, complementing Lumen and Huddle ray tracing, visual shadow maps are Unreal Engine 5 system for providing consistent, high-resolution shadowing. Traditional shadow maps often suffer from resolution limitation, leading to blurry or pixelated shadows, especially at a distance or when viewing very detailed objects. Video shadow maps address this by creating extremely high-resolution shadow maps that are virtualized, meaning only the necessary parts are rendered at full detail. This allows for incredibly sharp, accurate shadows, even for fine detail and individual leaves or strand of hair, for example. For players, again, this means every character, creature, and environmental object in The Witcher 4 will cast pinpoint accurate shadows that add immense depth and realism to the scene. These shadows will be consistent across distances, enhancing the overall visual fidelity and grounding objects more believably within the environment. Next is FastGeo Streaming and World Partition. This was designed to make seamless open world exploration. In general, building massive open world games used to be a very complicated task. This required developers to manually divide maps into smaller sub-levels and then painstakingly manage their loading and unloading as players move through the environment. This often led to visible loading screens, pop-in, or complex file management issues for development teams. Now, World Partition is Unreal Engine 5's automatic data management and distance-based level streaming system designed to provide a complete solution for large world management. Instead of multiple sub-levels, the entire world is stored in a single persistent level file, which is then automatically subdivided into streamable grid cells. These cells are loaded and unloaded on demand based on the player's proximity or other streaming sources. So you can see the thing here, everything is kind of virtualized. It's used when it's needed or when it's close to be needed. Working in conjunction with World Partition is FastGeo Streaming, a technology developed in collaboration between CD Projekt Red and Epic Games specifically to enhance open world capabilities. FastGeo Streaming allows environments to load quickly and smoothly, enabling faster loading of immutable static geometry with constant frame rates. This system is a massive leap from the textual loading issues seen in older open-world RPGs. For players, the combination of FastGeo Streaming and World Partition means a truly seamless and expansive experience in The Witcher 4's Kovir. There'll be no visible loading screen or jarring pop-ins as players traverse the vast landscapes. The world will simply appear, dynamically loading and unloading content in the background, ensuring uninterrupted exploration. This allows for an unprecedented sense of scale and continuity, making the world feel truly alive and cohesive. The tech demo specifically highlighted how FastGeo Streaming allows large open areas to load in seamlessly with no visible pop-in. So with these tools developed being released to all Unreal Engine developers, helping other studios create believable and immersive open world environments that deliver performance at 60 FPS without compromising on quality, even at vast scales. Next one is, bringing characters to life in animation and AI technologies. MetaHuman Technology. This is the next generation of digital humans. You can see, by the way, here some of the presentation for that on Epic Games. You can actually download even a tool to play with it. Amazing. Now, this pursuit of realistic digital characters has long been a holy grail in game development. MetaHuman Technology in Epic Games a comprehensive framework that empowers creators to generate, animate, and deploy fully rigged photorealistic digital humans within Unreal Engine 5. It provides a robust system for creating complex human models, complete with sophisticated facial features, hair, and clothing. For players, MetaHuman technology translates directly into incredibly lifelike NPCs and diverse crowds, each with expressive faces and realistic body proportions. This capability helps to avoid the common clone villager effect often seen in older RPGs, where many background characters share identical models, and again, contrastly with MetaHuman, developers can quickly generate a wide range of unique characters, ensuring that every encounter feels more authentic and every populated area feels more vibrant. The tech demo also confirmed that MetaHuman technology was used in The Witcher 4 alongside Mesh AI for crowd scaling. This means players will encounter characters who move and react with a level of realism that blurs the line between the digital and the real. Unreal Engine 5.6 has further integrated and enhanced MetaHuman capabilities. The MetaHuman creator is now fully embedded within the engine, streamlining the character creation workflow. This version also introduces the ability to create a near infinite range of possible body shapes similar to the facial customization options, and a new Unreal Engine outfit asset that automatically resizes to fit metahumans. This advancement is supported by the significant expansion of MetaHuman's database of real-world scan data for faces and bodies, enabling the creation of an even more varied range of higher fidelity characters. Next, we're going to talk about Unreal Animation Framework, UAF. Fluid basically leads to fluid and responsive movements. Character animation is fundamental to player immersion. The Unreal Animation Framework is Unreal Engine's next-generation animation system designed to eventually replace the traditional animation blueprint system. UAF has been built with a strong focus on performance and a, in quotation, paying for what you use philosophy, meaning efficient multi-threaded execution that largely operates off the main game thread and optimized memory use. For players, UAF translates into significant, smoother, more realistic and responsive character movements, especially in busy scenes or during complex actions. While previous animation systems like Animation Blueprint offer some multi-threading, UAF moves nearly the entire cost of animating a mesh to worker threads on the CPU, preventing bottlenecks on the game thread. This means that whether a series is engaging in agile combat, traversing challenging terrain, or simply interacting with the environment, a movement will feel exceptionally fluid and natural. UAF also introduces the concept of abstract skeletons, which decouples the animation graph from specific skeletons, promoting modularity, sharing, and reuse of animation assets. This allows animators to build assets they can ship as is without needing a nativization step, empowering artists to create more freely. And this system also leverages a deep integration of control rig and sequencer, covering the whole animation pipeline from authoring to runtime. The Witcher 4 tech demo specifically highlighted the Unreal Engine animation framework as powering realistic character movement in busy scenes. This focus on high-performance, artistic-centric animation system means that the fidelity of character movement will match the stunning visual detail of the world. The emphasis on paying for what you use and efficient multi-threaded execution allows for complex character behaviors and interactions without sacrificing frame rate, which is again crucial for fast-paced action RPGs like The Witcher 4. Next, we talk about ML Deformer, machine learning deformer. This provides subtle realism in every muscle. This is actually very, very impressive. Let me show you something first. Again, this is not actual gameplay, but it demonstrates the capabilities of this stack. As you can see, it's amazing. Look at the horse, the muscles, and how actually they affect the surface, and just super impressive. So while MetaHuman technology provides the foundation for photorealistic characters, machine learning deformer makes character realism a step further by adding subtle high-fidelity mesh deformations that captures the nonsense of the real-world physics and anatomy. The machine learning deformer is Unreal Engine approximates complex deformation models that are captured externally, significantly improving the quality of an in-game characters. It leverages Unreal Engine neural network inference and NI systems and the Deformer graph system, keeping all operations on the GPU for high performance at runtime. For players, machine learning deformer means characters that feel truly alive. Imagine seeing a character's muscles subtly flex and ripple under the skin as they move, clothing realistically wrinkle and stretch with body movements, or even skin that compress and deforms naturally with facial expressions. Now, these are kinds of subtle, realistic touches that machine learning deformer enables. It moves beyond simple bone-based animation to add a layer of organic realism that makes digital characters more believable and empathetic. The workflow involves training the ML deformer with large datasets of desired mesh deformations, often generated from complex simulations in external software like Maya. The Witcher 4 tech demo explicitly stated that the ML deformer adds subtle, realistic touches to character animation right down to the muscle movement. This commitment to micro-level detail in character animation underscores CD Projekt Red's dedication to creating the most immersive and believable characters possible. This technology ensured that even during intense combat or emotional dialogue, the character's physical presence remains utterly convincing. Now, I mentioned that before in a bit, we can talk about more about it now in more in depth. So Mesh AI, basically this is for populating the world with dynamic crowds. This leads to a truly immersive open world open world in general needs to feel populated and alive. How many times we hear people saying the world feels empty? So no more. People don't just want beautiful open world, they want them to be populated with things. So this is where Mesh AI comes into play. The mesh system in Unreal Engine 5 is designed to manage the behavior and visualization of thousands of AI agents, enabling the creation of large dynamic crowds and traffic. It utilizes the Mesh Entity System, a framework for data-oriented calculations crucial for simulating thousands of AI agents efficiently. For players, Mesh AI means bustling towns filled with diverse, believable crowds and dynamic battlefields teeming with reaction enemies. Instead of static, repetitive background characters, players will encounter intelligent NPCs that move, interact, and react to the world around them in convincing manner. The system allows for varying levels of detail for AI characters. For instance, in a city sample, for example, that showcased on their website, you can see that closest characters are fully rigged metahumans, while more distant ones are custom generated, vertex animated static meshes derived from metahumans. This allows, for example, for sidewalks to be populated with hundreds of characters. This approach prevents the world from feeling empty or artificial, enhancing the sense of scale and immersion. So if you complain about the things in many open world games, well, it's okay, you are there. The problem is, it's not that the developer didn't want that. Most probably it's the consequences of the technology. Now, the Witcher 4 tech demo specifically cited Mesh AI crowd scaling alongside MetaHuman Technology. So this confirmed that players can expect to see densely populated areas in Kovir with crowds that move and behave realistically, contributing to the game's overall atmosphere and dynamic encounters. This capability is particularly vital for an open-world RPG where towns and battlefields need to feel genuinely alive and responsive to the player's actions. The ability to manage such large numbers of AI agents efficiently, even when their numbers exceed several thousands, is a significant technical achievement, as the traditional AI methods can cause severe performance drops at high counts. So let's recap the advantages of Unreal Engine again for The Witcher 4. So The Witcher 4 choice to utilize Unreal Engine is a strategic one, positioning the game to benefit from the very latest advancement in optimizations in Epic Games' powerful engine. The strategic partnership between CD Projekt Red and Epic Games means that The Witcher 4 is not just using Unreal Engine 5.6, but is actually contributing to its development, with the tools and enhancements creating for the game eventually being released to Unreal Engine developers. This ensures that The Witcher 4 will leverage cutting-edge features designed to deliver a high-fidelity 60 FPS open-world experience on current generation hardware. And Unreal Engine introduces several key enhancements across open-world development, animations, and metahumans, all which will directly benefit The Witcher 4. So know that we can expect The Witcher 4 that built with this engine to stand as a powerful demonstration of the engine's capabilities and the fruits of significant strategic partnership between CD Projekt Red and Epic Games. The technological showcase including Nanite Foliage, Lumen, Virtual Shadow Maps, FastGeo Streaming, World Partition, MetaHuman Technology, Unreal Animation Framework, ML Deformer, and MSAI collectively promise an unparalleled open-world experience. Ultimately, The Witcher 4 is poised to not only deliver a next-generation experience for fans of the beloved series, but also to serve as a powerful statement to the evolving potential of Unreal Engine, allowing developers to craft truly immersive, high-fidelity open worlds that run smoothly and consistently. Thanks for watching.